Yeah, thank you for the nice introduction. And also glad so many people showed up. At least I'm not sure how the weather is at all places, but for me it's quite nice here. So I'll definitely go out for a beer after this. Um, so yeah, my name is Timo Hoogland. I'm from the Netherlands. I live in a small city called Apeldoorn. For those of you who have ever been to the Netherlands, it's a bit more to the east, central east. So far away from the big cities, Amsterdam and Rotterdam. Let me start also sharing my screen, which will be more interesting than just my face, I hope. All right. Can you see my screen, just to make sure?
Yes, we see it.
Awesome. And you also see this browser? Okay. So I thought it would be nice to do a short introduction of the different types of projects I work on. And then, because of course there's always too much to talk about and we only have a short amount of time, I was interested in focusing in or zooming in on one project that I've been working on for the last couple of 1.5 years or so. And that I'm very much interested in to explore further, and that is the drum performance with live coding and some machine learning and pattern detection. But before we get into that, so this is my homepage. I do all types of audiovisual performances and installations. Sometimes for myself, autonomous work, but also for other artists, or in collaboration with other artists. And I have an Instagram page if you like to follow me and see some of the stuff I make. So with my work, I always use Max, pretty much, I would say 90% of the time, but I also use other environments or programming languages like JavaScript and web-based stuff. And I mainly, as a solo artist, make electronic music via live coding, and for that I wrote a live coding environment or language that I called Mercury, which I will not really get into today, but if you have questions about it later, then of course I will be happy to answer them. But I would like to let you listen to a little bit of the things that I make with that, so you have kind of an idea. So this is a recording from a live performance, an algo rave we did in the Netherlands in April. It was 10-year anniversary of the algo rave scene or movement, I guess. And this was recorded then, so just a short piece. Etc. So I also make a lot of audiovisual stuff that I like to share with others. I also teach, so I'm always very happy to share my knowledge with students, but also in these types of meetups. And so I share a lot of work I make with Max, Jitter, or audio as patches on, for example, Gumroad, but I also have a GitHub, not this one, this one where I share abstractions that you can use if you like. So you're welcome to have a look at that. If you want, I can share the links as well later. And I teach Max at the University of Arts in Utrecht, the HKU, at the Music Technology Department, where they have different courses, not only for programming, but also for composition and electronic music and all those types of things. And besides that, I work closely together with Creative Coding Utrecht, which is a foundation that really tries to organize a lot of meetups and events about creative coding and art. And anything in between, and that's kind of like, yeah, that is interesting. And besides that, I am part of the Netherlands Coding Live community, which is a small community of live coders we have here in the Netherlands. I think we're with 20 people or something at the moment. And usually we help organizing algorithms or other types of events and workshops together with, for example, Creative Coding Utrecht, but also other parties. All right, so that's me in a nutshell. And so today I would like to talk a little bit about the project Drumcode. So I've been doing the live coding performances for quite some time, I think 4 or 5 years now. And before that, I have been playing in bands a lot as a drummer. I also studied drums way back. And I was still looking for a way to kind of get drumming back on stage together with the electronic music that I was already making. And I was really hoping to be able to perform drums, but also have kind of the freedom to jam with the computer, where I am not like forced into a fixed timeline of a composition or something, but actually can decide when next pieces will start or when instruments will be added or will be removed. And I was hoping to find a way to do that without having to like hit a sample pad or something that's like triggers the next scene or triggers the next sample or whatever. So I was hoping to find a way to listen to the patterns that I play on the snare drum or on the rest of the drum set and use that to move on to next parts in the composition. And that is kind of how the project started. And I thought it would be nice to, because the whole project is made in Max pretty much, there's some JavaScript as well, which runs in Node.script. So I thought it would be nice to kind of zoom in the different elements that I've been using and how everything is connected. And open the patch as well to show you how it looks under the hood, I guess, because that's probably what everyone's the most interested in, I think. But let's, before we do that, let's listen to a little recording of the performance. I have so many things open from Zoom that I cannot click on other stuff because everything is in a way. Wait, let me just reorganize a little bit. Okay. Right, so I would like to show you a little bit of the beginning because that kind of hopefully makes a bit more clear how the instrument works. And then I'll also skip a little bit to other parts of the composition where everything kind of like merges together. But I would like you to, if it is visible enough, I don't know, to focus on what I'm playing on the snare drum, and if you kind of also see what will be happening on the screen as a reaction to what I play, and then we can discuss the details later. So let's see, hopefully this will not be too loud. Okay, here we go. So let's skip a little bit further ahead to listen to some of the rest. All right. I can share the video if you like, and to see it in its full entirety later on. So to explain a little bit what you've been looking at, so the code that you see here is that is the Mercury language that I designed. So I still use that project in this performance, although I'm not really typing it myself, but I pre-coded all the sounds. And the language runs in Max actually as well. So it is a Max patch where the code is translated to the synthesizers and the samples that make the sound eventually. And let me go to the flowchart that I made. So I have these drum triggers on the drums. I'm not sure if you're still watching my webcam as well, but it's these D-drum drum triggers. They're not very expensive, and they're just a contact mic that you can clip on the drum head, so you can connect it via an XLR cable to your interface, and then you can pick up the sound. So I use those, and then I made a patch that translates the incoming signal to OSC messages in different ways. So I have OSC messages that react directly, that just send the amplitude value or trigger value when I hit the snare. But I also like to keep track of how many hits do I have per second. So and what is my average amount of hits. So I kind of have some stuff to play with in the code to change parameters of instruments based on if I play faster, there will be more distortion, for example, or more reverb or whatever. So basically from within this patch, it can go two ways. It can either go directly to the code, and then I can control parameters with the OSC messages from the triggers, or it goes to the patch that has the pattern recognition and that generates the code for me to create the sound. So in that patch, and I will show it briefly, or I will show it in more depth in a little bit. In that patch, I use the ML star package, and specifically the multi-layer perceptron, which is a classification neural network that you can use for a lot of different things. And I decided to try and use it for the pattern recognition. So what I did is I trained it on a preset amount of patterns. And then every time I play, I will try to match the pattern that I play against, or I try to classify it against what I have trained previously, and it will try to make an educated guess, I guess, and give me a result in the code. So then, based on the result of the code, or based on the result of the recognition, it will either remove an instrument or add an instrument. And in this case, an instrument is a small snippet of code that I made beforehand, or it will swap an instrument. And because I liked the idea of kind of having a jam session with the computer, where when you would be in a normal jam session with some other musicians, you can kind of feel that you are going into a change. There will be a verse or a chorus, or you will go to a bridge or whatever. But because every musician is an individual, of course, they make their own decision how it will sound, what the bridge will be. So I can make the decision that we will go to the bridge or the verse, but I do not know what the computer will actually be adding or removing based on the change that will come. And for that, I use a Markov chain that kind of allows the computer to make decisions on its own on what extra stuff will be added or will be removed. Yeah, so, and besides that, of course, I have this editor or this browser window with the visuals that reflects what is happening in the code. And the visuals are actually in this performance not jitter, but are coded in Hydra, which is a JavaScript-based live coding language. And it is WebGL, so the JavaScript code is translated to GLSL shaders. I would definitely recommend you check it out if you're interested. It is pretty fun. The reason I decided to go with the Hydra visuals eventually was because I also wanted this browser editor. And I had this editor, but then I thought, okay, then I can also use this browser page to create visuals with it instead of having to have a jitter window open and then also have a text editor overlay that and do like some OBS magic with, I don't know, some color keying so I can like see the text and also the visuals. So that is kind of how that came to be. All right, so I'm not sure how I am in the time, so let's have a look at the patches, because I guess that's where the magic happens. And then later on, if you have any specific questions, then please let me know, and then we can go a bit more into depth. So this is the patch that has that translates the triggers to OSC. And basically, the core of it all is the bonk object. So I have been also looking now with for those who have seen the package, the Flucoma package that has been coming around on the forum a lot. It's an amazing package. I also followed one of their workshops. So I am in the transition of maybe using that package in the future, because I got some good results with using it for some other project. But because I have so many I had so many performances planned, I will leave this for now. So because it works, but maybe I'll switch later. In any case, the bonk object gives me a bang or an integer value based on the incoming signal. And what I do with that for the rest is I have this calibration system before I start up performing. I use the calibrating to see how soft is my softest hit, how hard is my hardest hit, so that every incoming signal will be normalized between 0 and 1. So I know what to expect when I get the OSC messages later on. And also, so it will be always kind of the same without me having to make sure that the gain is always the same. And also, I don't always play on the same drum set. If I have a performance somewhere else where I'm not able to get the drum set myself and they will arrange something, then you always run in the situation that it's not the same as when you practiced at home. So this calibrating function has really saved me for that. Yeah, so on top of that, I have some gating, so I don't really get false triggers from, for example, the kick drum that also triggers the snare drum hit because of the resonance of the snare head. So that works pretty okay. So then, if I unpack this, I send those values as an amplitude value or a velocity value over OSC. But on the other hand, I also do this averaging of how many hits I have per second and what is the BPM that I am playing. And so I can also send those values via OSC in like these messages. I do have the trigger next to me, by the way, so it should be in a working state. Yeah, see. So if I just hit the trigger on the table because I don't have a snare drum with me, you can see that it is kind of detecting stuff and also how many hits there are, or if it is slower, then it will drop down. All right. So those OSC messages go to the pattern patch. And so what you see here in the presentation mode is basically these are the patterns that I preset beforehand. So I just use the matrix control here, and this is for now. This is just if you would say these are like 8 16th notes, pretty much. So it always tries to detect this group of 8 16th notes and the pattern within. So let me open this patch up actually. Oh, where did it go? There it is. Oh, I need to do this. So here we go. So these patterns are preset beforehand, and I can change them, of course, if I want to, but usually I don't change them during a performance. So because I also practice with these fills that I play, and then I use the MLP that you see over here. So this is the multi-layer perceptron neural network, and basically what I've done is I've just mapped these arrays of 8 values to one single digit, an index, 1, 2, 3, 4, etc. And the 1, 2, all the way up till 8 correspond with an action that the computer will do. So an action can be add a code or remove code or swap code or decide something randomly or based on the Markov chain, for example. And in the beginning, I just had a direct one-on-one pattern matching, so I didn't have the neural network in between. It would just see, this is the incoming list, this is the other list that is in the system. Do they match? Do something. But the problem I ran into is that I don't always exactly want to play any of these patterns. I might also want to be able to improvise, but I do want that I improvise that it actually does something. So that's where I decided to use the machine learning object, because even if I don't play any of these patterns exactly, it will still try to match one. And based on the result of what will be matched, there will still something be happening. So that is where it actually came in for me, or where I realized this would be the best way to work with this. So then based on that, I have a node script running, and in the node script, all the code will be generated or removed. I'm not sure how much time we still have left. I think maybe 5 minutes, 4 or 5 minutes or something.
Yeah, you can go. It's okay.
Okay, that's good. So I can show you a little bit of the node.script code if you like, although I'm not sure how many of you are into it. But I find the node.script has been very helpful for this, because there's so much text changing and things going around. I'm not even sure if I would have been able to do this with regular Max objects. So this is probably way too tiny to be able to read if there's a lot of compression on the video. So let me see if I can zoom in a bit. All right, so here are the actions. So there's an action: add, remove, swap, decide. And then here above, I have a dictionary that kind of decides, okay, if we are in the exposition, so the beginning of the performance, then the chances of adding something are low, but I want to be able to swap a lot, and I don't want to remove anything because it's the beginning of the performance. So if it would already start removing stuff while I'm starting the performance, then we have a lot of emptiness in the sound at a certain point. So I kind of fine-tuned these probabilities for this Markov chain based on trial and error. So I've just been playing around with it and seeing what happens, and that kind of eventually I came to these numbers. I might change them in the future, but for now I've been playing around with these for quite a while, and they work quite okay. So yeah, of course, this is all the code that tries to add and remove the lines. I'm not sure if that is very much interesting. So maybe I can show you the Mercury environment, and then that's about it. And then we can have a discussion later in the breakout room. So Mercury will be the sound engine, I guess, and it translates the code to what is actually happening in the music. And this is also a max patch, or it started out as a max patch, but at the moment there's also a JavaScript version for this language. But the max patch is way smoother. So the code from the editor is also sent via OSC to Mercury. And then in here, I have a poly object that basically has all the options in it that can be coded. So there's a synthesizer, there's a sampler, there's just a tone, filtered click, there's an FM synth, there's a polyphonic synth. There's also a synth for the kick if you don't want to have a sample, some Carplus strong synthesis, and then there's a chain of effects that are all wrapped in poly objects. So for example, if I open the distortion, then this is in a poly object. So with the bypass message, you can easily disable or enable the effect to save the CPU processing. So by default, all these effects are of course off, and all these synths are also off, of course. And then based on the code that is added, some things will be turned on, and the arguments will be passed through the system, and then triggered accordingly to the sequencer. Yeah. Yeah, like I said, there's of course so many things to talk about still, but I guess my time is kind of up. Maybe there are some questions for in the breakout room later, and then I would be glad to help you and answer them. But then I guess I will pass the mic now to Tommaso.
Okay, hi everybody. Thanks for inviting me. Thanks, Massi. Thanks also, Timo, for the very interesting speech. My speech, I would like to talk about my approach on algorithmic rhythms, computation-based rhythm, and the interaction between humans. In particular, I would like to speak about the compositional part. I would like to start with a little improvisation, a little piece live to show also some of my devices that are simple Max for Live devices that I developed for compositional purpose. So all the devices that I build are comes from a compositional idea. So I start from an idea, and then I say, okay, I need this and this, and I develop the device, and then sometimes I like the result, so I also share it, selling it in my in the webs in Gumroad. But basically, the devices are for my composition, so it's the main purpose of my work in development. So I start with this little live, then I show you how it works, the system that I play, and then I will pass to the to one piece video from a new project that I am working, and it will be released in the next year, but I would like to show you, and then I speak about the two of these compositions, also with the some score to show you what's the ideas that are in these pieces. So I'll start with sharing live, and with I stop my voice now, my microphone, and start playing. Okay, back with my voice. It's a little example, obviously. Now I can show you what's the system, how it works. Basically, is a is this device that's called, I call it scene, is like a pattern synthesis that creates the computational computation based rhythm. It's pretty simple. It's a sequencer of beats, beats changing. So these are beats that are changing, and here you have the repetition on every beat. So for example, if I am at 90 BPM, I have quarter notes, and if I have one repetition, I have a note every quarter note. If I change, and I was changing with this slider, all the repetitions, I can go from 1 to 2, so octave notes, 1 octave, 1 16, etc. And this is the core, because then there is a chain of notes. Here I have a sequence of note that I wrote. Here note chance that add some probability on these events. And one of my approach that you find in all my devices is the stochastic function. So you have randomness with probability. You can choose the percentage and the range for almost every parameters. For example, here there is the instrument, there's a calculus strong, and brightness, resonance, filtering, gliding is all with a little amount or big amount of randomness, and with a stochastic approach. Then the other tracks are linked to the first one with other devices that are SynBro and SynSys, that are sister and brother of Syn. In the fact that, for example, SynBro take a note, play a note every X steps. For example, here 13, with an certain amount of length. So it's related to the notes that comes from the main Syn. Also, the Syn sister, that is, for example, here, is related to the Syn mother or father, and it's SynSys. It goes to the effects. For example, to change a parameter on an effects with this mapping function, so you can map a parameter. Okay, then another thing that I like to do in my pieces is the interaction between the sounds between the tracks. And for doing this, for example, in this piece, I use gate with sidechain. I use envelope following that change parameters on other instruments. For example, here, no, here. And also I like to feedback these sometimes I like to feedback these chains. For example, a sound with an envelope follower affect its sound, so the same sound. So I like to do also these things. Other things. So this is basically because I like to make an organic timbre. I feel when I write, I think at a main timbre that is made by a lot of parts, and I like if the parts are really well connected and linked. And so this is an idea of the starting point of some of pieces that you will listen now. Now I would like to speak about this new project with a trio, with the pianist and the Indian tabla player. In this work, we worked on the concept of time, and so we saw this topic from a different point of view, from perception to quindi psychological perception of time, religious, philosophical approach, and also physics with physics laws like relativity, quantum mechanics, and some new theories. We are not physicians, but we like to study that kind of things for making music. And so with this approach, we released also other projects that are online, like one 15K, that is an album about physics laws, basically. And then I can show you this video that is not yet released, but will be released maybe in the first part of next year. So I change the share from here to QuickTime Player. Yeah. So this is the piece. It's called the Waves Flat Surface. I move to the second part where we have an interaction. Okay. Yes, this is an excerpt of this piece. Yes, we have we are three, and we have the mechanic part that goes like with solenoids. So the electronic part and also the rhythmic part that is where the one that we were talking about before is actuated, is done by not only the software and synthesizing part, but with also with the mechanic part that is very important in this project. So I built a mechanic solenoids structure with that plays on the keys and on the strings of the piano, also in other pieces of this project. So in this piece, basically, we like to we started from the wavy from a wavy time perception. A wavy time perception, like when an observer moves very fast with the speed close to the light speed. So according to relativity, it's like we like in this piece to show this wavy movement from the mechanic part to the pianist and tabla player part, that are a sort of polyrhythm. But the other level of this is the fact that both humans and machines fail, and they fail because they want to fail in the case of human, and because of the structure of the mechanic part for the mechanic part. So we worked on this. I work on this concept, and so there are some levels of composition. These are two of the levels. So the errors on the rhythm and the moving on these errors. So the humans that follow the machine and the machine that fails. So basically this is the piece. Also, obviously, there is some live electronics part that are related to this process. So they control also the lights. In this case, it is the live version. Controls light, mechanic part, and synthesized part. And this is another piece that I would like to show you. I do not have the video. We didn't record it, the video, but I have the part. So I can show you also how we write this on the scores, because I like to write the pieces on the scores, because for me the score clarify a lot of things that maybe we do, trying this, trying that one, but I like the score because it clarify it, show it, fix some the ideas. For example, this piece is another approach to time and with a human and a machine. Sharing this is a PDF. So, for example, the concept of this piece is in two-part piece. In the first part, there is a system like the one that I played in the first part of my speech, where there is a computational rhythm, algorithmic, that is changed by every stroke of the tabla. So the tabla, when tabla makes a big stroke on the instrument, it changes the notes of the bass in a sequence that we wrote. and change the subdivision of the timing machine that is seen, the one that we saw before. So here there is an explanation graphical, because I like the graphic part. Also in my devices, I am also a graphic designer, so I like to show in a simpler way the things that happen for me. So, for example, when I make the devices, I try to make a simple interface, because I like, when I reopen the patches, I like to feel comfortable, not doing searching for parameters, and I like when a patch make that thing with a small amount of parameters, and so I like also the visualization of this. So in this part, this is the main part of the first part of the piece, with description of the sounds and description of the process. So the piano follow the changing of the tabla. So the tabla made the change for the algorithmic part, and the piano, the game is like a game. The piano start to shift from the first timing to the next, and this is another type of interaction that I like. The one that, for example, we was thinking about the quantum physics and the quantum jump between a timing to another. So the mechanic part make this jump in a small amount of time, is very fast, and the human is different because must listen and then change. So we played with this different approach in this piece. So maybe we can listen, and then let's back to live. This is the first part of the piece. Okay, I think it's enough. Obviously, if you have question, we can respond later, answer later. Can I add this? I can show you, text you on the chat my website where you can find everything
Yeah, perfect.
about
I
me.
wanted to thanks, Tommaso. That's a lot of stuff going on, and yeah, I
Thank
love
you.
the idea of evolving main tempo thing. You know, it's and Reinhold was asking something about actuators.
Yes, actuators was the solenoids that was yes on some pieces are only on the keys and other pieces are on the strings of the piano. We need maybe grand piano or grand piano for making this. I build a structure that with some magnets it's attached to the piano, to the keys part of the piano, and with these actuators on. We change the notes for the piece, and yeah, that's it.
Thank you to both of you.